here.
Is it through the email?
Yeah.
Ooh.
Question is how much does a polar bear Jaden, how much does a polar bear weigh?
Oh. A polar bear weighs between, so an average full-grown polar bear weighs, so I guess it's not average, it's a limit, right? Weighs between 350 and 700 kilograms.
350 and through 700.
Kilograms, yeah. The in pounds that would be 772 to 1,540 pounds.
1,000 what? 540?
543.
Ooh. So, Jaden, this is something that...
But say that again.
So this right here is something that bothers me. This 350 to 700 kilograms bothers me, that people call that weight. Do you know why that bothers me?
Why? Because that is a mass.
That is correct. That is a mass unit, right? So it bothers me when people call that weight, because it's not actually weight. It is a mass unit. So, to actually know how much a polar bear weighs, we actually have to times it by the acceleration of gravity, because weight is actually a measurement of force. Okay, so the acceleration of gravity is 9.8. So if we calculate this, we get 350 times 9.8. You get 3.
I figure out how to get on the live stream.
Question.
Yeah, but then I don't know the answer, so I can't get on the live stream.
Oh.
How do I do it?
How do you get on the live stream?
Yeah. An old live stream.
This should be in the same channel.
I just keep seeing this one, but it's not from today.
Yeah, it is. You just need to.
This jacket.
Oh, that's.
I said it's not online. He said, no, we don't put a.
Oh, that was under Kip Quilter. Let me. Here, I'll send you an email with the link.
Cool. And then I'll hit pop right on.
Okay, continue, Kip.
Okay, so it's actually going to be this, right? Times 9.8 equals. What do you think that equals, Jaden?
Oh boy. Let's grab a calculator. Is there a way to pull up a calculator with that whiteboard?
I don't think so.
We have 6,860.
Cool. So.
And that's newtons.
That's newtons. Do you know who Isaac Newton is?
I heard he was like a guy that likes to watch apples fall from a tree, or an apple fell on his head or something, and he's like,
gravity.
There's a force here. Gravity. Right?
Exactly. And he claims that he invented calculus. Is that true, Mr. Mathematician?
Well, invent is a tricky word, right? There's several, like, okay, Kip, let's say you and I, right?
Yeah.
We discovered something brand new. We're both working on it. You're in America, I'm in Europe. We're both doing this at the same time. But let's say I publish the paper a week before you, and then you publish a paper, the credit goes to me, right?
Right.
Unless you're more famous scientist slash mathematician than I was, right? Then people might be like, well, even though it was a week before, I don't know about this. So that's the tricky part with that word, right? Invent. But anyways, Newton and a mathematician called Leibniz are people that are famous for inventing calculus. Fun fact: we use Leibniz notation for integrals, but Newton is often credited more often, I guess, than Leibniz.
Huh. How interesting.
It's pretty fun. Pretty fun stuff. So you're talking about force equals mass times acceleration.
Yeah. Jaden, do you know what a mass is? What is mass?
Um, isn't it anything with, I guess, substance, right? So mass could be any particle. I guess not any particle. We got to be careful with that one too. uh, any sort of like molecules, right? Any elements, all those have mass.
Yeah.
Um,
So,
yeah,
mass essentially what it means, my understanding, maybe I'm wrong, but my understanding of mass is essentially just how much of stuff is there, right?
right.
And the reason why you said we got to be careful it's not, not every particle is something like a photon is technically a
Yeah.
particle, but
And
it's
what is exactly is a photon?
a photon is a particle of light.
Okay. So,
It is something that is used in quantum mechanics to describe the behavior of light because light can both be a wave and a particle at the same
right,
time.
that's what I was going to get to next. Tricky stuff here. So, and then what is an acceleration?
So an acceleration, the units for acceleration, okay, are um, meters per second squared. All right. So I love using units to try to figure out what things actually are. Okay. So
Okay.
we also know that velocity is meters per second, right? So that's how far something's traveled and how much time, right? For us, I mean, this is one version of it, right? It's units of measurement of distance divided by measurement of time. Okay, so for us
Okay.
people in the United States, we're not very, we see a lot more of things like miles per hour than
Right.
meters per second. But and so what an acceleration actually is, the it's how quickly something's speed is changing, right? So you can think of speed as how fast something's moving. Velocity is with the direction as well. Um,
Right.
and then acceleration is how quickly that velocity is changing, whether it be the direction that it's changing or the actual speed at which it's changing. That's what acceleration is. So, like, the Tesla new Roadster that came out that is going to be able to accelerate in, what is it? It's like 60 miles an hour in less than 2 seconds.
That's pretty crazy.
That's its acceleration, right? So it's able to get up to that speed. And so it's got to have a
Well, in
large
2 seconds,
force, right?
60 miles per hour in 2 seconds. So that would be 30 miles per hour for every 1 second?
It's debatable.
Yeah.
If it's
Right.
average, right? So we're
That
saying that
would
it's
be
average. So its average would be 30 miles an hour per second, right? And if you look at the units, if we do this, right, we get 30 miles. We'll use a big M, okay? And that per means you divide.
Funny, right? We're talking about miles per hour and then also in seconds.
Yeah. So we got, whoops, I don't know. That's definitely. So we got miles per hour, okay? And we can do some quick unit conversion here, which is 1 hour equals 60 minutes, right? And then 60
Yeah.
minutes equals 60 seconds. So if we multiply that by
So that'd be
60,
360.
so we get to
So
that.
100. Yes, yes.
So that means they're going. Oh, wait, we got to be dividing here, huh? So we get this. We get this, like this, okay? Or, whoops. 30 miles divided by 300 or 3,600 seconds, right? And so then it's divided by seconds again, which gives us 300 divided by 3600 miles per second squared.
Right.
So that's your acceleration of the Tesla.
That doesn't seem like it's just groundbreaking just looking at it. Why when we change it to the seconds, why does it seem like it's not very fast, Kip?
Well, because that's how much time it's traveling in 1 second, right? So before we were looking at how much time it was traveling per hour, and now we're looking at how much time it's traveling.
The distance it travels in a sec. Okay.
So it's not as much, right? It's not as much as it would have been in an hour, but that's because in 1 second, it's got to cover a lot of ground. And again, this is the acceleration, right? So this is how quickly it's speeding up.
Right.
So.
Then every second, right, we can add more velocity to that, right?
Right.
Because if velocity tells us how much we're changing, we can just continually add on to the velocity so we know we are going faster and faster.
You're exactly right.
Awesome. Same thing works for like skydiving, right? But isn't there a terminal velocity? And what does that mean? If we're skydiving, right? Shouldn't we accelerate and just go faster?
Great question. So we got this guy, right? I switched to page 2, by the way, Jaden.
Great.
So here's this dude.